week 9. So as usual, I will take first your doubt who just came for doubt. We'll discuss those, and then uh, we'll do a summary kind of to try to summarize the week 9.
Okay, sir.
Sir, yesterday you told, sir, that there will be revision on week 6 and 7.
No? Oh,
Okay.
I took session after 1 week. I mean, so no, at where, like, from where you got this message?
Actually, sir, yesterday in TS session at 2 p.m.
Okay.
Okay. Yeah, sir told that if most of you will request, it will be converted into revision section or session of week 6 and 7. And
Huh.
he has given a Google form also, Google feedback form. And
Okay.
few of
So
us,
that's not a revision session actually. Even
Hmm.
actually, I proposed this idea to him
Okay.
that I said that I need a special session. I mean the activity session for logarithms because I am facing the problem in logarithms. So he
Okay.
said that if if he get 20 students for the session, then he can conduct. Then some person also proposed that he's facing problem in exponential. Then he said, okay, then we can combine both the topics in one if there are many students who want that. That's why he asked to fill the form.
Okay.
Yeah.
Okay.
Because sir, actually I'm lagging in logarithm because that
Okay.
time my Python exam was there and I couldn't put much attention to logarithm. So, and I even couldn't find any that activity sessions for that logarithm. And every time when I do, I feel like every time new formula is coming up. Maybe
Okay.
because I don't know, that's why. But
So
that's
no
why
issues.
I requested.
No issues. We can keep the session. That's not a big issue. So for 2 hour, sorry. For 2 hour, if there is such thing, so yeah, we can keep a session. Maybe TAs will take there. So probably. So if it is needed for week 5 and 6, for the mock, including the mock solution also, and for 5 and 6, no?
6 and 7, sir.
Sorry, 6 and 7. Okay. So that could be possible, yeah. And I hope the TS are good and they can clarify your doubt, they can revise your doubts.
Yes, sir, they are really good and they are going any extent to solve our queries. He's
Yeah.
really,
So
especially the Rakesh.
how the sessions like office hour and this or challenging
Yeah,
practice.
they are very helpful, sir.
So yes, it's very helpful.
Okay, and yeah, I've seen the many of you are requesting for this activity and practice session. So already I have given the uh, last activity and practice as to give. I have given access just those sessions are just recorded and uh, not on the stream. It will not all on stream. You will get those all on the calendar. Already you know those things and already given the access to watch those sessions. So
So for week 6 or which you are saying?
for like there is a session already held on uh, there is one session right on Monday and practice session at 2 to 4. Yeah, 2 to
Okay,
5
sir,
something.
which week, but which week?
That's depend on like for which week is going, like for this is
Okay,
like
for
the
every
next,
week you are saying.
yeah, for every week, for each Monday there is a session, practice session. It is
Mhm.
already attached, yeah, files are attached in calendar, yeah, you can see that.
Okay, sir. Yeah.
Yeah, somebody given the link also. Sorry. So you can watch there. So if it is needed, so Okay, so what they said yesterday at the yesterday 2 to 4 there was a challenging session, no? So how was that? Anyone
Yes,
have
sir, it was
anyone of you attended?
Yes, sir, it
Yes,
was
sir.
good.
Sir,
There
it
were
was good.
three
The questions
questions.
were really challenging.
Okay.
Mhm. Sir, actually, we haven't seen like these kind of very difficult questions, like especially the set problem, which they said it was good actually. The rest was okay, but the first question was really difficult.
Okay.
I think only one person got the correct answer. Rest everybody got the wrong.
So what were the attendance? How many persons have attended that session?
Sir, I think around 50.
Okay.
I'm not sure about the exact number, but it was around 50.
Okay, I forgot to ask the attendance and okay, we'll see that and the slide will uploaded in the same as live session slide. Okay, with the date. So we'll get the slide also. Maybe I'm not sure the challenging session need to record. That is not needed. Only the questions PDF is enough or slide is enough.
Sir, if it will be recorded, then it will be.
Oh, if the challenging concern you will get, so that's the not a big issue. The recorded the activity and practice session need to be recorded. Challenging is just you will get the PDF. That's all. Those questions are used to be discussed. So how many questions I have discussed yesterday?
3 questions, sir.
Okay. Okay, fine. So let's start the session. If it is so for revision session for 6 and 7 is needed to all of you. Have he circulated? No.
Yes, sir.
26. Okay. We'll ask to TAs and try to conduct the session. Okay. For 6 and 7. So 6 is on logarithmic only, and 7 is just sudden of the starting of sequence series limit continuity. So this is not a combination, no proper combination like just logarithmic then the sequence
Sir,
and series.
as far I remember, we proposed for 5 and 6, not 7.
Okay. Okay.
Actually, we proposed for 5 and 6. Yesterday in the feedback session also, we have given that comments for 5 and 6 combined session.
Okay. Okay. Yeah, this is the combination of like exponential and logarithmic.
Exponential and logarithm.
Yes. So okay, we'll ask to the TA and maybe 2-hour session will be probably on. Then Sunday we'll keep a session. Yep. Yeah, probably we'll ask to the TAs and if they are agree to conduct. We'll surely do that.
Sir,
Okay.
one more request is we are having the quiz 2 coming up on April 2nd.
Okay.
So I know that today you will release the week 10 assignments, right? So we will have the deadline falling within 2 days after the
Yeah.
So if it can be extended by till the end of the week, like Sunday or Monday of the week, then we will get time to revise what we have studied for the quiz.
Yep. I'm not sure, but probably maybe it will extend it, but I am not sure. Okay, as last time it has extended, I think week 5.
Yeah.
So I'm not
we had
sure, but
discussed,
we'll ask to the operational team and we'll decide that
yeah,
should
just if you could recommend, that would help, sir. Yeah. If you could recommend from your end, that would help.
Okay. Okay, we'll see that.
Yeah.
Don't worry.
Thank you.
Okay, let's start the session. Just a minute.
Sir, can you start with some revision?
Yeah, okay. So anyone have doubt on week 9? Please let me know, and then we'll
No, sir.
revise that.
No doubt. We can start from the revision of summary.
Sir, it's not about doubt. Actually, we haven't completed yet. So if we don't know anything, then we cannot ask you any doubt. So it's better if we go through the brief of the week 9. Then side by
Okay.
side, we can ask our doubts.
Yes, the same for me, sir. I have also not completed.
Same for me, sir.
Okay. Okay, so Okay, let's start now. Let me share my screen. I hope my screen is visible to all of you.
Yes, sir.
Yeah.
Okay, so on week 9 we have critical point, then computing maxima minima. In week 8 already we something known, no, critical points. In week 9 the critical points started with the critical point, then computing maxima minima, and then computing area, and then Riemann sum and integral to just get the flavor of integral, and integral and antiderivative, and the computing area using integral. Okay, so okay, so week 9, the critical points before to start the derivative, because the critical points came from. Please let me know once my voice is not clear. Okay, if it is there is an internet connection issue, please just stop me.
Okay, sir.
So critical points mean to say the first the critical points came before. To know about the critical points, before you have to know some derivative. So because finding a derivative of a function, if at a particular point the derivative is 0 of a function, so that's that at that point you can think as a critical point. So suppose you have a function, okay, from R to R, let's say, and okay, so suppose you have function, and at a point the derivative of a function mean to say or a differentiability. First we need to check the differentiability. If the function is differentiable at that point, once it will be differentiable, then you can find the derivative of the function at that point. So to check the function is differentiable or not, so generally there are if you are able to draw the graph of the function, and if you see that if you are able to get the tangent at that point, suppose you are able to draw the graph, and you want to if you are able to find the tangent while looking, just see that if you are looking the graph, just say that okay, this function is look like very smooth, and we are able to get the tangent at that point, then directly you can say okay, fine, there is no issue to say that the function is differentiable at that point. That is while looking the graph of the function you can tell. Otherwise there is a more mathematical or pure kind of thing, uh, this algebraic kind of thing. The definition is to a function is differentiable a particular point or not. Just this is the definition. Just a small increment in the function and value of the function at exactly at that point, and divide with the whatever the increment, the small increment you did. If this limit is exists, then you will say that function is differentiable, okay, at that point, and whatever the limit you will get, that is called derivative. of the function at that point. For example, you have already gone through, suppose you have a function, let's say x cube plus 5x square plus 5. So suppose you have a function, so already you have gone through the derivative formulas, which is if you just derivate that function, so that is you will get, this is x to the power n if you have a function, and if you derivate it will, you will get n will come to as a multiplication and time x to the power n minus 1. So this will become 3x square plus 10x plus this will become 0. Derivative of a constant function is 0. Simply mean to you cannot increase the constant function. If you do the small increment in the input, increment in the input, still the constant function means constant, and the constant become the whole thing. Still the constant means at that point like 5, and this is exactly value is 5. 5 minus 5 becomes 0. That's the meaning to get the derivative. Why the constant derivative, derivative of the constant function is 0? Because whatever the input increment you are doing in input, still the function is constant, and that's why the whole thing is still become the function value, constant value, which is 5 here, and already you have 5, and 5 minus 5 becomes 0, and limit will become 0. That's why the derivative of the function, constant function, is 0. So from here you can easily get those. So see that if you say that, see if you have a constant function as here, so now the critical points, suppose you have a constant function, so yeah, suppose you have this function, suppose fx is equal to 5, and you here you are able to see that when you are we are derivating it, so we are getting 0. So derivative at any point is 0. So if you see that for the constant function, the critical point, now there is word came when there is a property of the function, if the if the derivative of a function at a particular point is, you are getting 0, so that is called the you can say that point is critical point. And another definition, like another means there is another criteria, if the function is not differentiable at a particular point, that point is also a critical point. So there are two criteria to say that a function is a critical point, or not two definition, there is only one definition, but a point you will say a critical point if a point is a critical. Let's say you have a function from R to R, and A is a point, let's say x is equal to A. At this point, function derivative either, so if the function is differentiable, at A, then you will say differentiable at A, and the derivative of the function you are getting 0, then A is a critical point. Suppose function is not differentiable. Suppose function is not differentiable at A, then in that case also you will say that A is a critical point.
Sir, for this type of constant function, like you written fx is equal to 5, the slope should be 1, isn't it, sir?
Yeah. No, the slope is 0, no? The derivative of the
okay.
yeah.
Okay.
Derivative value of the function is 0, no? So this is the slope.
Right, sir.
So okay, this is the critical point. So for example, you can let's see some to find the critical point. So suppose you have a function fx is equal to, let's say here is
Excuse me, sir, I am not getting the last line. If not differentiable at A, then A is a critical. So critical point we find out like after taking the first derivative, we factorize and then we find the roots, right? And that is the critical, like at where we get the roots, correct? Hello.
Let me change it to. Am I audible?
Sir,
No,
Sir.
sir. After writing fx, your voice is not audible.
Sir, did you hear me? I asked a question actually.
Audible right now? I think my voice is breaking. Audible?
Yes, sir, you're audible.
Yes,
Yes.
sir. Now you are.
Sir, I have a question. Can you show the screen again?
Yeah, just a minute. Okay, I hope now. There will
No, sir. Your voice is not clear.
Sir,
Your
your
voice.
voice is breaking.
Am I audible right now? Okay. Okay, now I hope. Am I audible right now?
Yes, sir.
Okay, now there will be no issue. Okay. So suppose you have a function.
Sir, I have a question in this first. Sir,
Yeah.
I'm not getting the last line. If not differentiable at A, then A is a critical. What does it mean?
So for example, suppose you have a function fx is equal to mod x. Okay.
Hmm.
So is this function is differentiable at 0?
No.
So in that case, you can say that 0 is a critical point for that function fx.
Okay. And sir, what does it mean when we differentiate and then we find out the roots? And then also we said we find out the critical points, like at where it is 0. So that is a critical point, right?
So for mod x, 0 is a critical point, as at 0 the function is not differentiable. Okay.
And
So
sir,
And
the
for
function which you write x minus 1, oh, you
yeah,
have
so
put in the mod. Okay.
yeah.
But
So
sir, let's say
let's
if it is not in
investigate.
the mod, so if let's say if it is not in the mod and then we find the critical point, then also we can find the critical point, right? X is equal to 1 and x is equal to 2. That is also a critical point, right?
No. In that case, so if suppose you have function fx is equal to simply without the mod,
Yeah.
so still you need to derivate it. No, once you
Yeah, the
will derivate,
first derivative, and then we have to find the factors, right?
then find the root. Then find the
Yeah.
root. Whatever you have function, then
So
find the
let's
root
say,
of the
sir,
function.
after taking out the derivative, I have got this factors x minus 1 and x minus 2. Let's say this is
In
f
that
dash
case,
x,
in that case, the roots are going to be 1. Sorry, their critical points are going to be 1 and 2.
1 and 2. Okay.
Yeah.
Okay, sir.
Sir,
So-
what is the pictorial representation of critical points, sir?
So critical points mean to say, in the pictorial form, where you will find the sharp corner, okay? Where the function have
Okay,
sharp corner,
sharp.
where the tangent is not exist, mean to say where the tangent is not exist, those points you will say a critical point, okay? And already
Okay.
you know the turning points, no?
But sir, then we have to check whether the point is differentiable or not.
Yeah. So critical points where the sharp corners are there, function is not
So-
differentiable at that point.
So
You know
if it is
already.
not differentiable, how will we find f prime? If
So
it
if
is
the
not
function is not
differentiable-
differentiable, so no need to derivate, no. So just say that, okay, this is a critical point. No need to derivate. The function is not differentiable. That's all. Okay. At that point, the function is not differentiable, you know. So why you are going to check? Already you know that that function is not differentiable at that point. So why you are going to, like, that function is not differentiable, then how you will get the derivative?
But sir, picture will be not given, but there will be the function will be given.
So in that case, you have to investigate. No, so you have to investigate. Okay, at which point there is a possibility that that function is differentiable or not. So you have to investigate for that. Like for mod x, you have to investigate. So as usually, you know, the mod is kind of already many of you, if you once have tried, if you have function fx is equal to mod x, so using the limit definition, you have to investigate that at 0 it is differentiable or not.
Okay.
This
Clear,
is the process of it.
Clear, sir.
So critical point in pictorial form mean to say a sharp corner, mean to say a function is not differentiable at that point, and those points is going to be the critical point, and where you know already the turning points. So these are the turning points. Like function is increasing to decreasing, decreasing to increasing. So turning points are going to be your critical point. So there are in pictorial form, there are two ways to find the critical point, the whole critical point. So mean to say in this interval of the function. So how many now the critical points going to be? Let's assuming to be the, just exclude the end points. Okay, remove the exclude the end points. So in this interval, how many turning points are there? Sorry, critical points now you can tell me.
Sir, it is 4.
So four critical
four.
points. So as at this point is not differentiable, so this is going to be a critical point. This is a turning point. This is a turning point. This is a turning point. So three
Can you give one
turning point,
example of such type of function? Means
so maybe this one, you will see this one. This is going to be an example of similar kind of thing. If you draw the graph of this mod. So let's see that. So so hope you are getting no. So these are the four critical points are here. Okay, four critical points. So if you see that graph of fx is equal to x minus 1 and x minus 2 in the mod. Okay, so how can you tell me what is going to be the graph of this function? 1 and 2 is going to be root. Okay, here is 1 and here is 2. And at 0, there is a problem. Mod creates problem when you have function is 0 value. So as you know, the mod is equal to mod x. Sorry, fx is equal to mod x. So function at 0, there is a problem. Because there is a problem with the sign. That's why there is going to be the sharp corner. So for 1, it is going to be a sharp corner. For 2, it is going to be sharp corner because of these points are going to be the root. So at root, there is a problem when we have the whole mod. So that means it will be like this. The function value always will be positive. So I don't know how it will go, but I don't know how it maybe directly will go like this, increasing and increasing. But in this, in the small interval, in this till this area, I am very much sure that the graph will be like this. Because, okay, 1 is the root, 2 is the root, no issue. And then bounce back to like this. Okay. So maybe the graph of the function is this one. I'm not sure. But yeah, in till here, I know that the graph would be like this. So it will be not a straight line. It will be look like a curve. Okay, like this. It will
so
be
if
also
mod
like
would be not be there, then this parabola should be opposite to x-axis. That is inverted.
so if it is more, not more, yeah, generally what is that? If you have this one without the mod, so
then it will be
what
cross
is the graph of this function?
parabola.
1 and 2 is going to be the root. So this one probably.
Yes, sir. So
Right?
that the lower part is inverted.
Yeah, lower part is inverted because of the mod give the positive value always. This will become like this.
Yeah.
And you have to erase it. Because of this, that's the process to draw actually the mod function. So where the roots and where you are getting the negative thing, just revert it that. So this is going to be the graph of mod, this one. So now, can you tell me how many critical points are here?
1, 2, 3.
3.
3, sir.
3, sir.
Three critical points. Three critical points going to be because, okay, this point is going to be a sharp kind of thing. because of when you revert it, no, so this is kind of smooth, but when you are getting the positive thing, it will directly it will be like a corner because of the mod. So this is going to be a cornered side. At this point, your function is not going to be differentiable, as you know, you are unable to find the tangent at that point. Corner at the corner, you are not get the tangent. So where you are unable to find the tangent, that point is actually at that point the function is not differentiable. The reason is, if you are unable to find the tangent means you are unable to find the slope of the line or slope of the tangent line, and actually derivative give the slope. So you are unable to find the tangent means you are unable to find the slope, means you are unable to get the derivative of the function at that point. That means that function is not differentiable at that point. So that's why the top corner is going to be a critical point, work as a critical point. So this one and this one, these two are points where function is not differentiable. Because of that, this is going to be a critical point, and another one is there is a turning point. This one from increasing to decreasing happened here. So because of that, this is going to be a critical point. So what is going to, can you tell me what is the exactly point?
So it is a vertex.
Vertex. Yeah, that is one thing. Yeah, that's a good thing. This is going to be a vertex of the parabola. So what is the vertex of the parabola here?
It's 3/2.
So minus not minus will have, no?
3/2.
3/2, no? Not minus will come. Minus will be, yeah, minus.
Minus will cancel.
So this is going to be a 3/2. So can you tell me, so vertex, yeah, that's one, that's the very good thing. Without knowing to be the derivative of the function, you can tell. Can you tell me now the what is going to be the using the derivative, finding the derivative of the function using that what the second definition, not second definition, the second criteria. Derivative
Yeah,
is 0. So what is that? What is going to be using that? Can you tell me that? What is going to the derivative of the function here?
2x plus 3 equal to 0. F prime will be 2x plus 3, 2x minus 3
3 is equal to,
Yes.
yeah.
Equal to 0.
So before to proceed, see, this function is without the mod. Can you tell me that function, whatever you have, this mod, fx is equal to mod x minus 1, can you write in the step form? Can you tell me how it will be in the step form?
Step form will be,
Separately, you have to deal, right? You have to, in the positive case, you have to in negative case, each time you have to do a separate.
So, sir, x minus 1 into x minus 2, if x is greater than 0, greater than or equal to 0, and minus x minus 1, oh, sorry, 1 minus x minus 2, if it is less than 0.
Okay. So while looking the graph, can you tell me now how it will be? Because you know the, so suppose something you know. So can you tell me how it will be like?
yeah,
How,
x
what you
minus
said?
1 into x, in my x minus 1 into x minus 2, when x is less than 1 or
Greater than, sir.
greater than 3.
No. So say what you have to do in this area, you have to find this area, you have to make a separate thing, and this area. In this, sorry, in this interval, and this
There will
interval.
be 3 intervals, no, sir.
3 intervals. There will be 3 intervals. So in the each separate interval, you have to count it.
And the normal graph will be from minus infinity
It
to
will be the
1.
minus infinity to infinity, but you have to make a separate thing in the interval. So it will be less than here.
So,
Yeah.
sir, x, if x is from infinity to 1, then
No, so you know the graph of the parabola, no? So this is the graph of a parabola. So you know already in this area, this is positive. So just make it positive. And in this area, there is negative. And this is the area. In this area, this is going to be negative. So just make it positive, give them negative sign here and make it positive. So this is
So
going
the
to be
first
one.
condition will be, first step will be true for the x when x is greater than 3. No,
X
sir.
is greater, sorry, X is greater than 2.
Greater than, okay, greater than 2. Yes, sorry.
And again, you know already in this area, the function value is positive. So just make it positive.
Okay.
This is the way you will write. Sorry, this is x is. Here it is, you can make the strict thing. So in like this, your step you will
Sir,
make it.
X
While
greater
looking the graph
than
itself,
2,
you can tell.
Greater
Sorry.
than 2, no, sir?
Yes, sir.
Oh, sorry. X is greater than 2. So while looking the graph of the para, you can make a step.
Greater than equal to 2, no, sir?
So already you have given the greater or equal to here.
Okay, okay. Yes, yes, yes.
Either you can give here.
How to compute this without looking at a parabola?
So then you have to be without looking the parabola, then you have to consider no. So how you will think that okay, without looking the parabola, so just think you have this function, okay. So when it will be positive, when you are thinking the x is less than 1, then how it will be. So I think I'm making a mistake here. I think okay, let's see that how it will be. So if x is less than 1, no, it is correct. So think that if x is less than 1, so this will give negative.
Yeah,
This
I
will
got
give
it, sir. I
negative.
got it.
Getting no?
We will find the value of x where the equation is going negative. And
Negative. So when x is less than 1, it is going to be the negative. Negative become positive. Okay, then fine. In the less than case, without negative, it will be. When x is less than, x is greater than 1 and less than 2. In that case, the value will be negative. So you have to give minus before the whole thing. Then it will become positive in this interval.
yeah, sir.
And the next thing is when x is greater than 2, so this is positive, then multiplication will be positive, then find this will be without sign of negative. So like this without looking the graph from here, you can conclude that how the steps you will take.
Right.
This is actually a good thing. You need to practice because many times mod will help to clarify many things regarding the differentiability and derivative continuity. So okay, so now you want to derivate this. So sorry. So what is going to be derivative of this function? So each time, like see at the where you have problem, no, here is the jump. At 1 there is jump, at 2 there is a jump, and before that the function is nicely we have like a polynomial or it is a quadratic. So what you can do, just derivate in the interval wise, because in the small less than 1, it is a polynomial kind of thing. Just derivate this. So what is going to be derivative here? Sorry, this is exactly derivative what we get here, 2x minus 3. You can multiply and derivate it. So this is going to be 2x minus 3 when x is less than 1. What is going to be this one? This is minus sign of, again the derivative will be 2x minus 3, right?
Yes, sir.
And in the positive case, again, we will get the same thing when x is greater than 2. So in each small, like in this interval, minus infinity to 1, the derivative will be this one, because in the separate interval you can easily get that okay, this is a small this is a polynomial and these are the smooth, and you can directly say.
Sir,
the problem
do we have derivative at point 1 and 2? Because
so yeah, so after doing this you have to check and find the derivative at 1 if the function is differentiable or not. So once you did, so see, this is not I just directly did this, but what you will do, you have to check first, do in this interval, then at 1 do check that function is differentiable or not. In this interval separately deal with that 2, then beyond 2. So you have to check those all using the definition of derivative. But we know already that okay, already something we know the graph, that's why I just did that. Okay, already we know, looking the graph, that okay, these are going to be the corner point, that's why the function is not differentiable, going to be not differential. But you have to check it using the definition of the limit of a derivative of the limit definition of derivative. Okay,
sir.
And once you did this, So this is going to be derivative of the function.
So
So
because you have written this one equal to less than it should not be there, no?
1 equal
One
to
at 1 and 0.1 and 2, the derivative is not present.
so yeah, you have to now erase it. Yeah, there is a mistake I did. This one. So derivative is going to be this one
Yeah, yes, sir, yes.
without the equal to sign. Yeah, that's the good thing. I just missing. Yeah, let's make a confusion also.
Yeah,
So because already you
that
know
was
that.
I asked earlier also, sir.
Okay. So at already that 1 and 2 is not differentiable at 1 and 2. That's why you need to remove the equal to sign. So it will be a strictly thing. So okay, now you need to so now you have this derivative. So you need to find the critical point. So already suppose you check that okay 1 and 2 is going to be at 1 and 2 the function is not going to be differentiable. So 1 and 2 is going to be a critical point. Now you have to find the where this is going to be 0. You have to find the value of x where the derivative is going to be 0. That means this whole thing is going to be 0. So let's do the separately in each interval. So if you do this one in the first interval, in this x is less than 1 case. So this, if you assume this is equal to 0, this gives x is equal to 3/2. But this value is less than 1. No. So you will not consider. So say that you will directly say that there is no critical point beyond the less than 1 case. Now back to here and check that. Okay. So again, the same equation is there. You will get that, okay, x is equal to 3/2. So yeah, 3/2 is lying between 1 and 2. So you will say that, oh, so now there is a critical point at x is equal to 3/2. So already we have investigated using the vertex of the parabola, which is already we got 3/2. So x is equal to 3/2 is going to be a critical point. Now check for the beyond 2. In this area, again, if you do that, so again x is equal to 3/2 you will get. So is 3/2 is greater than 2? No. So that means beyond 2 there is no critical point. Okay, is it clear?
Yes, sir.
Clear, sir.
Yes, sir.
So this is the process. So I took a abstract example also to get that how you will get the critical point. So this is a good example to investigate. So each time, so now I hope if you have a step function or any kind of function, what you will do, just write the steps of the function. Okay, just derivate in stepwise and be careful with the sign. I just missed it. This is a more he just make me careful, otherwise this will a bit confusing and you will get confusion, but actually this will not happen. So be careful with such kind of thing. Okay, once you did this all in the careful manner, then just investigate in the each interval where you are getting the 0 derivative 0 and collect those points and say that x is collect those points, and those all points are going to be the critical point, including the where the function is not differentiable also. So sorry.
Sir, if there is no mod function and no sharp corners, then how will we will break this break like this?
So if there is no sharp corner, there is nothing. So why you need to break it? Why that is going to be the smooth then, and a smooth function generally a polynomial you can
To
say, or
find the
sine,
critical
cos.
points. To
Sorry?
find the critical points.
Huh.
So to find the critical points, we need to break.
No, you break the here because your function is already in the step function. This is a step function. That's why you break. Otherwise, your function is not like your function is simply this one. No, suppose x cube plus 5x square plus 2x plus 2. So suppose your function is then, so is there there is any need to break this function? There is nothing. There is, this function is smooth. Means this
Okay,
is a
so we will
polynomial.
find the number of bands only.
Only the turning points. Just find the turning point. Let me mute who is Alok,
Hello.
Maria. Okay. Yeah. Okay. Okay.
Sir, for this function, critical point is just minus 10, right? You just have to equate 3x square plus 10x, 3x square plus 10x equal to 0, right? X equal to 0.
Yeah. This is going to be now just derivate. Okay. This is going to be 3x square plus 10x plus 2. Now find the root of this polynomial. So you know that there will be a 2 root, I think. Yeah, if you investigate that, how whatever you already know, this is a quadratic. So it may have 2 roots. So suppose alpha and beta are 2 roots for this polynomial. So critical points is going to be for this function is alpha and beta. Okay.
Yeah, yes, sir.
Okay. Now once you find the critical point, we are done with the very much while looking the graph and while looking to be the algebraic portion of thing like and the pure kind of thing. So we are done with the critical point. That's all about the critical point. Once you deal with the critical point, so there is one term came maxima and minima and saddle point.
Yes, sir.
So see, so if you have a critical points, so suppose this set, suppose you have a function from R to R, and this set is actually collection of critical point. Mean to say just collect those all critical point. Let's say alpha and beta, I just collected. Okay. So in a set. So once you collect it, so this critical point can give the maximum value of the function. Mean to say at alpha, the function have maximum value, could be maximum value, or at alpha could be minimum value or saddle. What do you mean by saddle? Means you know already via the graph. What do you mean by say maxima minimize? You know already the turning points. This is going to be the maximum because turning points, this how you used to calculate. So this is going to be your maximum value, local maxima. Mean to say local maxima. This is going to be local minima. So if you already know for the graph of x cube, no, you know the graph of the x cube function.
Yes, sir.
So you know at 0 it's look like a turning point, but that at 0 that is not a turning point. You know already for the x cube case. So in that case, this is going
The
to be a saddle point.
saddle point case will be clear if the order is higher. I mean, if it is x to the power odd but higher, like 5, and so the point will be more. The derivative will be 0
Yeah, derivative will get
for a longer
0.
Period.
Yes. So, so this is what the graphical mean to the saddle point means. It's look like a turning point, but not a turning point as the case of x cube. So these are actually the saddle point. Your function that at that point, this you will get the derivative 0. Okay, but that is not going to be a maximum minima. Still a function is continuously from increasing to increasing. The small kind of like this, but still your case is like continuously increasing and increasing, as here increasing and continuously. There is a small like this. So these cases are called a saddle point. So
Sir, for all odd degree, it will happen.
for all odd degree mean to say for this one
odd degree of zeros, 0.
Odd degree of
Odd what?
no. There is no mean to
It
odd
can
degree
appear
of
in a
0.
polynomial also.
Sorry.
It can appear in a polynomial also now, sir.
This x cube is a polynomial. It could appear in a polynomial.
Yes.
Okay. So right.
So critical points can be maxima, minima, or saddle point. Okay. Okay. Okay.
Then
Critical
the
points.
maxima and minima will be only one for polynomials, or there are many. Means every bend we can call it maxima or minima.
Local maximum or minimum.
Local maxima, yeah. The bends are going to be the maxima, minima, but yeah, mean to say the function should be from increasing to decreasing or decreasing to increasing.
So it doesn't mean that it is the maximum point of curve.
The maximum
Or
value.
minimum.
So for the whole, the maximum value of the function, like the case is this one.
That's
Suppose the case is,
absolute, right? Absolute
yeah.
maximum.
Suppose the case is this one. Now back to always the case here for the whole infinity. So this point is going to be the local maxima, but you can say this is a global maxima. Absolute maximum value also we can say.
So how could you find? How could we find that?
Absolute.
Absolute.
And the other two, sir, that is
Global
local.
max-
So these are local maxima.
And
Because you have a value
greatest-
more. See, these are the local maxima. Local means in the small interval there is a star. There is a maximum value in this small interval. But this point is the whole interval minus infinity to infinity. In this interval, this is going to the maximum value of the function. But this one is in a small interval you have the small maximum value, or mean to say turning points. We already know the turning points. Okay, so that's why this is local or global, mean to say. Okay.
So how can we find the global maximum or minimum?
So you have to compare then. So already you know. So say local or global is already a local maxima. So from using the critical point, you will get that, okay, this point is going to be the local. So see, this is already a local maxima, you know, already using the critical point.
Sir, your voice is breaking.
No, it is
No.
clear.
Yeah. Yeah. So you know already this is the local maxima. So just compare with the other local maxima. If it is
Okay.
always greater than 0, and compare with the function also, function value, just try to approximate always the function is negative value from this area.
Okay,
So-
that substituting that value in the equation, right?
Yeah, in the
Okay.
function, we try to compare that, okay, it is going to the always positive, or sorry, always greater than for any value of the function, then you will say directly to this is going to be the global maximum. So already using the critical points, you will get that, okay, this is going to be the local maxima, but you need to compare with the values of the function.
Okay, sir, clear.
Okay, so so the critical points can be maxima, minima, or saddle point. So how we'll get that this critical point is going to be the local maxima or local minima or saddle points? So how you'll investigate that? So for that, you know already once you have derivated that and you got that alpha f prime alpha is 0. Now derivate once again. So you have function from R to R. Derivate this function once again. Okay.
Yes.
You have derivated it. Okay. Now just find the value of the function at double prime. Okay. I think I'm missing. Yeah. That is for, okay, for the multivariable case, that is, yeah. So if this is the double derivative now is suppose the double derivative is positive, then alpha is going to be the local minima. Okay. If double derivative is less than 0 at alpha, then it is going to be local maxima. And suppose you got that double derivative at alpha also 0. Okay. In that case, you are going to be the you still you need to investigate it. So again, try to derivate it. Okay. Third time, and you are getting 0 again. Then in that case, alpha is going to, you will say that is going to be the saddle point. So further, you have to investigate, like for 2 time, you have to investigate still. So how the sir, let me see that how the sir is saying the video. Let me once just what sir is saying.
In conclusion.
Inconclusive, no? Yeah,
Yes,
for
sir.
the double derivative case, if you are getting 0, then that is inconclusive. You have to investigate. But for the third time, you are getting the, once you derivated the third time, then in that case, still you are getting 0, then you can directly say that is going to be your saddle point.
So I hope this picture is in analyzing how so we will first find critical points. So suppose f is differentiable. So is every at this point, it's not a tangent. This function is a, so D is actually a, if f double prime A is 0, then the test is unfortunately inconclusive. And that shall feel sad. This is not a absolute question. We will see why that's the case later on. Okay, so let's quickly conclude by recalling what we have done in this video. So we have checked how to where
Sir, have solved any problem on the saddle point?
No, sir,
Huh?
no.
No,
Actually,
no.
sir, first derivative test always get the correct answer, not second and third derivative, fourth derivative.
First derivatives try to get the critical one. First derivative gives the critical point. Second derivative gives the maxima minima.
Also he give local maxima and local minima by looking just sign.
The second derivative.
No, sir, just first derivative. Also he getting the
No, first
I'm
derivative, if you are derivating, so science
actually
tells you the function is
yeah.
increasing or decreasing. Okay.
Yeah, I'm knowing, but I'm solving the question from class 12th and class J main. Also, I'm solving by the first derivative. He getting always correct answer first derivative.
No, for using the first derivative.
Yeah, he give both thing. He give both thing, but just we need to find out sign.
Okay. But using the first derivative, you cannot conclude the critical point is going to be the maxima and minima. Okay. So see that if it is a derivative from see the test is fail. But for the here is again you have to for the this is for the multivariable case. This is still a multivariable case. Okay. So I'm unable to see the test is once it will see the if the double derivative is 0, okay, so just derivate the third time. Okay, if the third time derivative is going to be 0 still, then you can say that that point is going to be the saddle point. For example, see that for the x cube, see for x cube you have suppose your function fx is equal to x cube, just derivate it, you will get 3x square. Now critical points, you want to find the critical point, just make it equal to 0, you are getting x is equal to 0. So you got that, okay, 0 is going to be a critical point, fine, 0 is a critical point this for this function. Now just derivate again. So what is that? I'm making oh sorry, here is a small mistake I did. So this is the third derivative is not going to be 0. See that as here, I'm just making a mistake here. So see that what is happening for the cube. So if you are derivative here, you are getting 6x. Okay. So see that double derivative at 0. Yeah, I made a mistake here. I was always saying through derivative is 0, 0, but the third derivative at a particular point you are getting non-zero. In that case, that point is going to be your critical, saddle point. So see that here, when you substitute it for the second derivative, you got 0, unable to decide the sign. Now for do the third derivative, which is 6 here. Now substitute here, still it is a constant thing, so 6. Am I audible?
Yes, sir.
Okay. So third derivative, see that the third derivative is kind of
This third derivative
non-zero you are getting. So already you know that critical point is at 0. So third derivative is going to be a non-zero. In that case, we'll say that that point is going to be a saddle
But
point.
hello? Hello, sir?
Yeah.
But
Yeah.
sir,
Hello. Am I audible?
it is not
Yes, sir.
always possible like a third derivative or getting a constant number or fourth derivative of constant number.
Okay.
Just take example 12x ki power 9 plus 45x ki power 8 plus 40x ki power 7 plus 40
Yeah.
x ki power
So
2.
actually, see, yeah. See, what do we mean that if you think that again for the x to the power 5, okay,
Yeah,
for
so
the x to the power 5, if you do the third derivative, you will not get the constant thing. So what do you mean that?
here
You
here
have to.
here we solve by first derivative. Easily he solved. Just put the 0 is a critical point and
Okay.
taking
Okay. Huh.
taking the sign. Just go to the right hand side. Right hand side, it means they are greater than 0. So we need to taking the value which is greater than 0. So that is 4, 5. So it is always positive, and here that is getting always negative. So that is a local minima. 0 is local minima.
Okay.
But according to this, you saying this is just what it is, which is another point. I don't know.
Okay. So what you are going for 0? What is what could be like 5 is going for 0? For you have function fx is equal to x to the power 5. So what about 0 for this function? Is this a critical point? Fine. Is what is it is local maxima or local minima or saddle point?
Local minima.
Okay. So how you are sure about this? It is going to be local minima.
Just find out the derivative.
Critical
And
turning
find out
point.
Okay, 0 is a critical point. Fine. So
Yeah.
how you are sure that it is going to be a local maxima or local minima?
Find derivative and check the all possible critical point and write down on the number line and just go to the right hand side. Just take any random number like
Okay. I'm okay around
Sir,
the
like
0.
we
Okay.
can take -1 and 1, and then we can put the values.
Okay.
And then we can
So
see that the curve will go negative to positive. Then it is a minima.
okay.
Yeah,
So
yeah,
let's say let's
it
say
is
I'm
minima.
making it 5 x4. Okay.
Yeah.
Now can you tell me it is going to be 0 is going to be local maxima or local minima?
0
How
is
you
a
are
local.
sure?
I'm saying 0 is local. 0 is now also if fx is equal to 5x ki power 4, it is also a local minima.
5
And
x to the power 4.
I'm saying because of just taking the 0 is a critical point, and go to the right hand side and go to the left hand side. Put any random number like 0 to infinity, any random number. We know that always getting the positive number.
But x to the power 5 will be the saddle point, no, sir?
Sir,
No,
because
actually,
it's positive to positive, there is no turning.
Yes.
no, actually, what is happening here? For when you are derivating it, you get 5x to the power 4. So at 0, so
So
at
here both side positive. So here is the only one increasing. Not here. If you taking 5x ki power 4, then it is 5 for the 20x ki power cube. Then it is giving the local minima at the 0. But here fx
Okay.
is equal to power 5. It is not a local minima.
So what is going to be 0 here? Critical point or saddle point or local maxima, local minima?
Which one function? X ki power 5 or 5
No,
ki
x
power
to the
2?
power 5 we are trying to investigate. So how you are concluding? So 0 is going to be local minima, local maxima or saddle?
X ki power 5 at a 0. At a 0,
Yes.
it is increasing, not anything, not local minimum, not local maxima. Then what? Both hand side positive.
So what is then? Can you conclude it is going to be local maxima, local minima, or saddle?
It is saddle point.
How you are concluding?
Mathematically, pictorially, we all can say.
Mathematically, I'm saying,
How would you prove?
just because of both hand side, the both same sign.
No,
Uh-huh.
sir, for x to the power 5, both will not have the same sign. One will be negative and one will be the positive because
No,
because it
you
is 0, right? And we have to take one value from the left and one from the right. So we will
No.
take one -1 and a 1.
No, actually you differentiate. So you focus on 5x.
No, but when we put the value, we put the value in f of x. We don't put value in f dash x.
No, you need to put f dash x. That is the first derivative
dash.
rule. First derivative rule is that you putting the value which is on the right hand side and left hand side, put in the f dash x, not fx.
No,
If you
fx. You have to put
fx.
value in fx.
Fx, yes.
Not f dash.
Take example sin x. Take
So,
example
sir,
of
for x to the power 5, the value we should get the minima.
F
Minus
dash
to
x is
positive.
the slope, na? It is not the curve. It is the slope.
just take x sin x, then you saying.
Let me now conclude it. Okay.
Yes, sir.
Sir, I am
So-
not getting all this.
Yeah, I actually there are two mistakes I did here. So
Sir,
first
can
thing,
you revise once again on this?
yeah, let me tell you. One mistake is I said, okay, this is going to be 0. In that case, still your test is unconclusive. Like in the third derivative, you are getting 0. Still, you are unable to tell. Okay, like if the case for the x cube. Sorry, for the x to the power 5. Actually, 0 is here going to be a saddle point. Let's see how it will be a saddle point. Okay. The first thing I made a mistake that the third derivative is 0 and then we'll say saddle point. No, still is there is a problem. And if it is the third derivative is still your non-zero, then from for the x cube it is fine. Okay, the third derivative is going to be non-zero, then it is a saddle point. See, there is a process to check that directly. Like if you are derivating the third derivative, fourth derivative, fifth derivative. So if you are doing the odd derivative, for suppose you are derivating a function, okay? Suppose you have a function and you are derivating, suppose alpha is a critical point. Alpha is a critical point for this function. So you did for the odd derivative third time, 5 time or 7 time. In that case, you are getting a non-zero derivative at alpha. Then you can conclude 5 times, 7 times. How many times there is a possibility to derivate at the critical point, and if you are getting a non-zero, then you can conclude that is going to be a saddle point. Okay. Another way is just derivate once. Okay, at alpha you are getting 0. The alpha is going to be a critical point. So you know that at alpha the function is the derivative gives 0. Now what you can do, you have to investigate while looking the graph of the function. No, not graph, you have to investigate using the sign of the derivative. Suppose you have, as you derivated at here, the x to the power 5 and you got that 5x to the power 4. So if you say that if a small interval of 0, now think about the small interval. Let's say I'm taking the small interval, mean to say, let's say -1 to 1 itself. In this interval, what is it? What could you tell about this sign of this derivative?
Sir, at 0, it will be 0.
It is always positive in this interval. Means, yeah, in this interval, the derivative is always positive. No, in this interval, it is always positive.
Sir, it will be equal to 0 at
At 0, greater or equal to.
yeah.
Means greater or equal. It will be 0. Always positive value, and at 0 you will get 0. Otherwise, always you will get positive. Okay. What it mean that? What's the derivative give?
Saddle point.
A derivative of function, if you are derivating a function and suppose in this interval, let's say -1 to 1, the derivative is always positive. What it mean that?
So that means curve that at that interval curve not it is
means
not
slope are just increasing.
turning.
It means that function is increasing in that interval. Always.
Yeah, only increasing, not turning.
It is not turning, it is always increasing.
So it will be saddle point.
So see that what is happening here now. So in this interval, it is increasing. At 0, it is going to be 0. What is happening then for x to the power 5? It is always increasing, increasing, small, there is a small thing, and then again back to like this. Okay.
Yes, sir.
Means this is the mean, na? Increasing, 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 and still increasing. But yeah, it's look like there is a small term. So using the, like, this is the investigation. Using this investigation, you can tell that, okay, 0 is going to be a saddle point. Now is it clear?
Yes, sir. Sir, can you take one more example of point?
So let me tell you with the derivative also. Still, it is Riemann to derivate it using the derivative. So see, at 0, it is 0. You do the second derivative. What is happening here? This is 20. Okay, 20x cube. At 0, still it is 0. Do the third derivative. It is going to be 60. 60x square. Okay, at 0, still it is 0. Do the fourth derivative. So this is going to be 120x. Still it is 0. Okay.
Yes,
Now do the fifth derivative. See that what is going to be the odd derivative. Fifth derivative. Now it is going to be non-zero. So, okay.
sir, what does it mean, sir?
That means your 0 is a critical. Sorry, it is a saddle point. So odd derivative. See how much possibility that you are derivating, and the final thing that, okay, you are getting a non-zero, odd time non-zero if you are getting.
Okay, if
You are
I am getting a 0 at fourth derivative, then it will not be saddle point.
still your test is unconclusive. But once you did the fifth time, okay, odd time derivative.
If I got the 0 at fourth time only, then it will not be a saddle point.
Still you need to investigate. You need to do the further derivative. And at alpha,
If I got the 0,
Mhm.
then how further I will go derivate?
For further just derivate, no, at 0, it's like 4 time you have derivated to the 4 time, still at alpha you got 0. Just derivate it fifth time.
So let's say we got 60 at fourth derivative. Then what is
60 at 4. Okay, at 4. Okay, at 60 at 4 derivative. Oh, okay. In that case, okay. In that case, see what is happening here. So if the even case you are getting positive value, in even case you are getting positive value, then you will tell that that is going to be increasing, but that's not sure. That is, I have to check it. I'm not
Still
sure.
you
But
have
if
to
you are getting
investigate.
positive, you can say that is going to be local minima. If it is negative, then you will say that is local maxima. Okay. But still you have to, while looking the graph or from, as we investigated from this one, as here, using this investigation, using the sign of the function, try to investigate. See, so these are, I'm not very much sure. I have to check these all, but I am very much sure when you are derivating the odd time and getting non-zero, that then in that case, this function is going to give the saddle kind of thing. But the best thing is just investigate using the sign of the function. As it is going to be increasing or increasing to decreasing. That's the best thing to do this one. I'm not sure about it. I have to take, maybe if I will take the next session, I will more clarify it, okay, how the thing is. But
Yes, sir.
for the time being, I have to check it this all. Okay, but that for the time being, this is the further investigation, mean to say, as the test is inconclusive, you need to the further investigate, and if you are investigated and using the sign, you can conclude that it is going to be a settle or okay. For the fourth case, if you are getting 60, no, so if you derivate the only 4 time and you get the 60, that is a positive. So in that case, I know that in that case you can directly say that is going to be local minima, as that is a positive. But I have to check once. I have to check these all. Okay.
Sir, if you don't mind, fx is equal to ln x by x. If you take the example, it clear my confusion. So I think the everyone confusion are clear.
Okay.
ln
If you have a function fx is equal to log x
ln x by x upon
by
x.
x. Okay. Okay. Fine. Okay.
Yeah.
So you want to find the critical point for this function.
Yeah, critical point, local maxima, local minima, everything you find. Then
Okay,
I
so
think
what is going to be the first derivative?
First derivative is critical point I found E.
Only E.
Yeah.
Okay. Okay, let's do let's derivative. What is the derivative here?
It will be the quotient rule. applied.
1 by x into x minus ln x into 1 upon x square. This is going to be right. So this is 1 minus log x with
And
base e
x
upon x square.
minus x
Now
square.
make it 0. So this gives log x is equal to 1. So x is equal to e is going to give for one value. So that's why e is a critical point. Okay. E is a critical point. Now, can you tell me about at 0? See, still E is a critical point. E is one critical point. What about the 0? Then this function is not defined at 0, right? What can you tell about the 0? Till now you didn't find the all critical points. Only one critical point, E. There is a possibility to find the another critical points. How will get that? Can you check for 0? At 0,
No,
the
no.
function is differentiable.
No. We not check about 0 because the 0 is not in domain of ln.
So, but still 0 is not in the domain of ln, but you need to check that see, you have function is, that's the meaning of here. See, what about let me tell you the for example x to the power, let's say like it's look like a function. Let's say fx is equal to x square minus 1 upon x minus 1. Okay. This is the function. Okay.
Yes, sir.
So what is going to be the limit at 1?
Limit at 1. It is
Yeah.
2.
It is going to be 2. Limit is
2.
going to be 2. So suppose I am defining a function like this, x not equal to 1, and for 1 it is going to be 2. So this function is now well defined, and it is going to be a continuous. This function is going to be continuous because the limit is 2 and the function value is at 1 is 2. So that's why this function is continuous. So for this function, okay, I need to make it like this. Okay, fx is equal to, if the case is here, ln x upon x when x is non-zero, and when x is 0, what is going to be the, what I will keep here so that it will become a well-defined at 0, what I need to give it? Let's say I'm giving 2 here itself.
Yeah.
Okay, now it is fine to all whole real number. This is on whole real number, this is fine. Oh, for the negative, because for the negative. No, for the negative, x should be always positive. Okay, for this interval, it is fine.
Yeah, this is the trick of this cube.
Okay. I am just missing. So 0 will not investigate because the function is not defined there. Okay, I said this is. I said this is okay.
Saddle
So
point.
I just given x is equal to
Asymptote.
at 0. I just given the value. Okay, 2. Okay, fine. Now the function is defined in this interval 0 to infinity. Okay. Sorry, I just missed that. Now in this interval, okay. For this case, for this function only, in its domain, the domain of the function is in this interval. The domain of function is this one. The critical point is only E. Okay. And for this function, the domain of the function is close interval 0 to infinity. In that case, the critical point is E, and you need to check the critical point at 0 also, because at 0 you have the function already defined. So at 0, the function is not going to be continuous. If you find the limit as limit x goes to 0, limit x by x, what is the limit of this function?
1.
1.
And x by x equal. So it is 1.
It is 1.
Yes,
Yeah.
sir.
How are you
That's
sure about it?
ln by ln. It is a standard form, sir. I
Yes,
think.
sir. Yes, it is standard form.
It is a standard form, sir. So the limit is 1.
Yeah.
Okay, how will okay in the video, sir have told this is limit is 1.
Sir, it is a standard form. lnx is lnx
What
is
do you mean
limit.
by standard form? Sorry, what do you mean
But
by
it
stand
is
when you
formula,
see?
formula, sir, formula.
Okay, so this limit is 1.
Just like sin x by x limit extended to 0 is equal to 1. So it is a standard formula.
Sir, isn't
Okay.
it log 1 plus x by x?
Yeah, actually that's the thing here. But let me see that. What is that standard form? Let me. Okay. Let me check once. What is that? This is log x, or where is the solve with assignment for this? I'm just a bit confused. In the log, I think it is already given. And sorry, in the solve with assignment.
Sir,
Okay,
I think it's all with us week 7.
yeah, it is in the week 7. I think log x plus 1 would be. I'm not sure. Let's see. No, there is nothing. Okay. I think in week 8, sorry, week 7, week 8. Key points. Differentiability, just jump to the differentiability. That sin x by x is fine. Sin x by x is the limit is 1. For log x, to check it. Let me check once. Yeah, this is given for, I think, yeah, it is given for log 1 plus x by x. I'm looking in the chat. This is log 1 plus x by x. It is given 1, I think. Because this limit is not exist. Log x by x. So we can check easily. I am making a mistake. There is no issue. So see, using that you know already.
Sir, where can we get all these formulas?
It is already sir have noted, right? In sir have already given. How will get that?
Sir, can you provide a PDF of all such formulas?
Just a minute.
In supplementary documents, it will be useful, sir.
Okay. Just a minute. Let me check it once again.
Sir, actually,
Yes, sir, I checked. You are right, sir. Log
I
1
find
plus
ln
x by x equal to 1.
not exist,
Yeah.
sir. Not exist.
Yes, sir. We
It
are
is not
wrong.
For this limit is not exist. For this
Yes,
one limit
yes.
is not exist.
Yes, sir. I found I got it. Left hand limit and right hand limit both are unequal.
Yeah, for if you check that limit is not exist. So for this case, it is the standard form is given, I think, for limit x goes to
Sir,
0.
if we don't remember the
ln1 plus
formulas,
x.
how to
ln1
find
plus
out?
x.
Sorry.
Sorry, sir. ln1 plus x by x is equal to 1.
Yeah, for this case. So
Sorry.
for this case, you can, why this is limit is 1, directly using the indeterminate form. Using the indeterminate form, you can say, see, this is a 0 by 0 form. Now 0 by 0, you can now just derivate the numerator and denominator and get that, okay, limit is going to be 1. For this case, it is not a 0 by 0 form. The function at 0 is not defined even. Okay, and this is 0, a kind of, this is minus infinity, or the function is not defined. This is not the case for indeterminate form. That's why it is difficult to find the limit. And actually, this limit is not exist. Okay. So
How will find the limit of this function, sir?
this one.
Ln x upon x.
So limit is not exist for this function.
By first
So,
principle.
so how to be sure, sir, actually?
So for this one, see, you don't know with the epsilon and delta definition, but yeah, using that, without that, you can easily conclude, like, see, for the case as for the case for left and right limit. So all we need to go see that we will not include the left limit. So left limit, because the domain of the function itself positive side, means x approaching to 0 from the positive side. So for this case, how we'll prove this one? We need to show it unbounded. Okay, let's see that limit x goes to 0 positive ln x by x. So as x approaching to, this is going to be ln x on 1 by x. So ln x, the graph of ln x is this one. And 1 by x, the graph of 1 by x is what? This one, right? I think, yeah.
Yeah, it doesn't exist, sir.
So it is kind of minus infinity, and this is kind of multiplication of as x approaching to minus infinity to kind of this one. See, are you able, see, at 0 there is any like graph of ln x by x. What is going to be now the graph of ln x by x? Well, using the graph, you for this kind of function, while looking the graph, you will try to conclude that how the will the limit exist or not. Without that, you need to know the definition of epsilon delta definition of limit, but for this course you are not considering the definition. So just assume that's why the sir have given the standard definition, the standard limit. This is going to be limit 1 sin x by x by give the limit 1. But why? Because you don't know this epsilon delta definition of limit. So you can assume this is also a standard, say that this is not exist for these cases. Okay, for the time being. Otherwise, see, there is more critical, more in-depth definition that is called epsilon delta definition of limit. And using that, we need to prove, but I'm not going to discuss this here, because once we'll start, then it will never end. You need to know what is epsilon, what is delta, why this is all.
Okay, okay, sir.
So if you say the particular thing, we can find it online.
Particular means so you see, while looking like it, from this case, you can think that okay, this is kind of like minus infinity to the product of undefined number to undefined number. The infinity is undefined number. So that's why it is inconclusive that if x is approaching to 0 from positive side, the function is not approaching to a fixed number.
No,
That's-
what should we know? So what is that epsilon delta principle, or what?
That is definition, limit definition of the epsilon delta definition, limit definition.
Okay, sir.
So so in its domain, sorry for interrupt. So if you have a function fx is equal to log x by x, in its domain, the domain of the function is 0 to infinity. Okay, in this domain, the critical point is only e. Okay, fine. Now somebody says, talking about for this one, okay, you have a critical point, then
sir, just make a number line and put it 0 and infinity on left hand side, put 0. Not so double, not we do the double derivative.
okay,
because-
without the left hand side is 0.
Yeah, make a line.
Okay. Okay.
Yeah, and put 0 left hand side, just left hand side, pura left.
Okay. Sorry. No,
Pura
how you
left.
are in concluding that this is going to be a saddle or not, or a maxima or minima?
I'm saying, I'm just putting on the side where you make the point, just write E.
Sorry, E. Okay, sorry, E.
Yeah.
Yeah.
And on right hand side, no, sorry, sir, where you make the dot, put E, write E.
Yeah, that's fine.
Yeah, and the right hand side, put infinity.
Okay.
Infinity, and yeah, and take 5 and putting the f derivative x. I'm
Okay.
taking 5. I'm taking 5 because of 5 is greater than E.
Okay.
And
Okay.
putting the derivative.
Okay.
And it getting, I think, negative. Negative 5. Yeah,
Okay.
it getting negative. And take any number which are less than E, and it getting positive.
Okay.
And
Okay.
so it is local maxima. E is local maxima.
So see, if you in the derivative you are in concluding. So without the graph, how are you concluding? Like it is 5 here and less than 5 is positive. Then how you are concluding? So let me deal with that. Let me deal with. So you have a function. This one, the first derivative. What is that we got? We got 1 minus ln x upon x square. No, correct. This is the This is that first derivative. So yeah, this is the first derivative. Now again derivate it. Let's see that what will happen. So again derivate it. What is going to be this one? This is going to be 1 by minus 1 by x into x square. Okay, minus this is going to be 1 minus ln x. Okay, this is 2x upon x to the whole square. X square the whole square. So this is going to be minus this is sorry, this is minus. This is 1 by x minus here is okay minus 2x plus 2x ln x upon x square the whole square. Now substitute here e. What you will get? F double derivative e. This is going to minus 1 by, let's take the, okay, from both sides take the negative sign here out. This is here and this is 1 by x and this is plus. Inside will be 2x 1 minus ln x.
Sir, 1 by x into x square is x, right?
Sorry, yeah, I am making this. Sorry, this is going to be x. Okay. So now substitute e here. So this is going to be minus e plus, sorry, here is, okay, plus 2e and this is 0 upon e to the square to the whole square. So this is going to be minus e by e to the power 4. So this is negative. So at e, what is going to be the critical point e? What's give?
It's local maxima.
Local
According
maxima.
to double derivative.
Yeah, according to the double derivative, it's give your local maxima.
But according me also, it coming the local maxima.
Okay, so see how you are concluding. You are concluding the first derivative and the sign of the derivative. Using that, you are concluding.
Yeah, first of all, I'm knowing the 3 rule. If the point is like critical and if left hand side is negative and right hand side is positive, so the point is that local minima. If the point is critical, if the point is critical and right hand side is positive and left hand left hand side is positive and right hand side is negative, so the point is local maxima. And if both hand sides same sign, it means that what is point? Saddle point.
Saddle point. That's fine. Yeah, if you have both sign is either it is negative or it is positive, that is the case for the saddle point. That's fine. Yeah. That's the good thing. That's the good thing. That is, that is kind of while looking the graph, or you are just looking the structure of the function and concluding that is going to be a maximum. That's good thing. That's fine. No issue. Okay, either whatever we have using the second derivative test, Using that, we can conclude. And for the saddle case, just conclude as we concluded here for the x to the power 5 case. Okay. Just look the sign of the derivative. And if it is positive or if it is negative in the both small interval, if sign is still positive or still negative, in that case, that point is going to be a saddle point, as here. In this case, always in the small interval of 0, it is positive. So that's why 0 is going to be saddle. If it is suppose the case always negative also, then still it is a saddle point. Is it clear to all of you?
Yes, sir.
Yeah. Now, a maxima minima is done. We completed an example also on kind of difficult example, not much difficult. Okay, so now next is I think we quickly do the next thing. Where is that? After limit and maxima minima, there is
Area.
Riemann sum. Riemann, no?
Yeah,
Area. So computing area, I will not going to discuss that. That is just for the getting the flavor of the Riemann. Riemann is actually, what is Riemann sum? Riemann sum, okay, we'll discuss now. So what is Riemann? Okay, I have one slide. Let me show you. Where is that? Slide is I think this one. This one. So if you see this, this is giving the flavor of Riemann. So what is under the Riemann? In that whatever the area of what is that area of something is written there, computing area. So in that, sir is trying to tell you, if you have a figure, okay, let's say if you have a square, you want to find the area. So what you will do, suppose you don't know, you know the formula only. If you suppose you know the formula to finding the area of a square, okay. If you have a square and you know the area under this square is whatever you have, let's say A is one side, so area is going to be A square. Suppose you have only this formula and you want to try to find the area of this rectangular box, this rectangle. Okay, sorry, yeah, this one. So how you will try to get? So you will try to divide in small square in the square form. If you are trying to divide that whole figure and do the sum, suppose you divided the whole this area in the square, suppose whatever this possible square is there, so you just divided possibly all in the square form. Okay, once you divided and calculate each area of the square and do the sum. So see that only you know the area of square, using that you got the area of this rectangle, this and this whatever you have. So yeah, so using that this one, you got this area. So how you did? You find you break the whole area into the square and did the sum, do the sum. That's the Riemann sum actually. So what is the Riemann sum? Suppose you have a graph of a function, this one, okay. So and you want to, sorry, this, okay, this one you have. Suppose this is A and this is B. So suppose you have a curve, and under this curve, what is going to be the area? You want to calculate it. So how you will calculate? So this is the same process. So you know already to finding the area of a rectangle here. Suppose now, as you did for a square, suppose you know already to find what is going to be the area of this kind of say rectangle is going to be, suppose you have side A and this is B, then area is going to be A cross B. So just divide the small that whatever you have area, just divide the whatever we know using that formula, we will try to get the area. Suppose this is going to be so this is going to be it is forming a kind of this shape. This is just now just divide this one or in the rectangle. Okay, like this, whatever you like, you are try to break the whole area in the small figure, whatever you know the area, and do the sum all. So as here, so if you have suppose this one, okay, if you have this graph, you have this function, graph of the function, okay, under this whatever the area enclosed this interval, this graph have done this, whatever the area under this curve you have, you want to find that. So how we'll get that? Just break those area in the small rectangle or square kind of thing, and then try to find the area. The same thing as here. Now, if you see the definition of the Riemann sum, so what is the definition of Riemann sum? If you want to find the area under this curve, so this interval is AB. So just break this interval into the small interval. So I suppose I want to divide this interval in, let's say, five small interval. Okay, in 5 small interval, I want to divide it. So here is AB. Let's say I am assuming to here. Okay, let's say B now. Okay. I want to divide this in the 5 small interval. So how I will divide it? Just take the breadth. What is the distance between this? How much this distance? Okay, just divide it. So this is B minus A, and this is going to be 5. So now what you can do, you can, if you add A plus B minus 5, B minus A by 5. So this area is now, I divided, let's say this is 1, this is 2, this is 3, this is 4. Okay. This is 5. 1, 2, 3, 4, 5. Okay. Let me erase it. I have interval this one. Okay. In equal distance, I mean to say these are the equal small interval, equal, who each have the length same length. Okay. So these are the 5 small interval. So this is now the next thing, you just divide this distance with the 5, and now this point is going to be what? A plus B minus A by 5. Okay, now the second one is A plus B minus A by 5, and at this distance, this much distance is what? This is B minus A by 5. Okay.
Sir, how, sir? I didn't get this.
Okay, suppose let me take with the real number. Let's say I have 2 and 5. Okay, I want to divide in the 3 sub interval. I want to break it in this 3 sub interval. So how will divide it? You know already 2, 2, 3. Suppose here is 2, 3, 4, 5. So each have, I got 3 interval, right? Small sub interval. This one. So how will get? So how you'll get this? If you want to divide, so this is what is the distance between these two small, this 2.1.
5 minus 2 divided by 3, sir.
Yeah, 5 minus 2 divided by 3. If I want to find, the 5 sub interval or 3 sub interval, just divide with that number. Take the distance between that point. So this is 5 minus 2. This is going to be 3 by 3. This one. So each is interval, you can say the distance between the sub interval here is this one, and this one is going to be 1, 1, 1, like this. So I am doing the same thing here. I want to find the distance between, I want to divide this interval in the 5 sub interval. So what I can do, just take the distance and divide with the 5. That is going to the breadth. You can say breadth.
Sir, you taken the first dot as at A, And the second dot is a plus b minus a upon.
So how you will get that? So if you add, see, you got the, here is 1, right? So 2 and whatever this one I
No,
added.
I got it, sir. But
Yeah.
the third dot should be a plus twice
2
the
times. Yeah, 2 times. So I need to be add. I still remain. So the same, whatever the distance you got, like whatever the breadth you got, add 2 times that. Mean to say 2 times. Here it means 2 times this one.
Okay, sir.
That's the meaning here. I just started writing, but you stopped me. That's why. So this is going to be 2 times b minus a. So that's the process. Now, what we did here, we try to find the area. So we in this interval of this curve, under this curve. So I just divided that interval in the small sub interval. Okay. Now, suppose this one is this one is this one is here, and this one is here. Now find the area of this box. Now again find the area of this small box. So how you will get that? So find the upper, there is upper case. We know the area only the rectangle. So find the upper case here. Similarly, for this one, find the upper case here. For this one, find the upper case. Okay, find the upper case here, same thing. That is called upper sum, upper Riemann sum. And similarly, you can think about the lower sum also. Like here is this one, just try to make a rectangle as here. This is again the rectangle. This is a small rectangle. Oh, this one. So what is happening here? There is, see, for the upper case, there is a small error. When you are trying to divide this area in the small rectangle, there is a error. The extra sum is this one. The extra sum is this one. The extra sum is this portion. So there is an error. There is error happening when we are doing the sum, taking the whole sum in the survey after doing the small. When you are thinking the small, when you are thinking the lower case, lower sum, then again there is a small. We are missing this area each time. Okay, everyone is getting this one, no? What I mean to say, what I am discussing.
Yes, sir.
Yes.
Okay. Now, so see, for each case, when you are thinking for the upper sum, there is a error. For the lower sum, there is a error happening for both cases. So how I will rectify this? How I will rectify this? So there is one way to rectify it to, or how there is a one way to minimize this. That's the come here limit thing. So what we can do, see, I did for this in the 5 sum interval when I divided. So it has become give this much bigger area. Suppose I divided this interval very small. Let me now make another picture. Okay. I divided this now. Let's say this is A and this is B here. What I am doing now here, in the starting, I divided this interval in the 5. Now let's suppose I am doing the same thing with the 100 sub interval. If you do this, so this error is going to be lesser than that one. What is happening when I am increasing the interval? Small. When I am dividing the interval in the small interval, what I am getting, error is going to be lesser. Error is each time. Suppose I did for 1000 times, then again the error will be lesser, whatever in the upper and lower case. So suppose what I did the case for, let's say, n time. I'm not sure what is n. And I said this as n goes to infinity. Mean to say I divided the subinterval in what it mean that as n goes to infinity. I am taking the number n. I am taking the number n very what?
Very small, very infinite.
No, very large number. No, very large number. I am taking the number, very large number, and dividing with that.
Okay.
So that means what? I'm doing I'm breaking this interval very small.
Yeah, that's what I want to say. Breaking it into very small.
Very small. And then in that case, if you take the sum, it will give the exactly. So for the limit case, now see, I took the very large, then that's fine. Suppose I did this for the n goes to infinity, mean to say
B
very,
minus
very,
A
I'm not
will
including.
approach to 0.
Very, sorry?
B minus A will approach to 0. If
Yeah, in this case, yeah, this is B minus is going to be 0. You are taking this whatever the distance, whatever the sub interval you are trying to divide, that is very, very, very means very small, tending to 0. And in that case, if you take the sum, it will give the exactly whatever you have the area under the curve. And that's the came here Riemann sum, the same Riemann sum. What is the Riemann sum now doing? So Riemann sum is tells you now the definition. If you see the Riemann, what is that Riemann? There is two cases, upper sum, lower sum, sir have discussed. Let me show my case here. Okay. So see that the same as here. Okay. Okay. Now see that the same thing is here. See, this is the upper case. Each time I include in this area, this extra area. Okay. For the lower case, see that for the lower case, each time I'm missing or either, yeah, each time I'm missing this area. When I did this. Each time I'm missing this here. So what I can do, I can do this with the very, now see, this is the n is equal to 10 here. I divided this interval in the 10 portion, like, okay. This divided in the 10 sub interval. Suppose I increases this. See what is happening here. See, this is giving the exactly sum, no? Slowly till 100, but still, if you see that there is a missing portion, but somewhat refined than this 10. See that for the 10, for the 10 or 20, this one is more refined. Similarly, you can see that for the upper case also. See that for the 10 or 16, see this area is more. But when I increases, when I divided this interval, more smaller is smaller. What is happening? We are getting some refined area. Okay. That's the meaning of Riemann sum also. So what is definition now? So how we'll get the area of rectangle now? You know, let me now give the Riemann sum definition. Suppose you have area of, I want to find the area in between here. So this is, suppose you have a function, this one, and display. Suppose you have a function, this one. The graph of the function, this is f of x. Okay. Now I want to find this area. So suppose I divided this is b minus a by 5 in the 5 sub interval. So this is going to be the a plus b minus a by 5. Okay, fine. So how much this distance is? B minus a 5. Okay. And this distance, and how much this is? What is going to be this one? So I want to find the area of this box. How will find?
Fx, sir.
Fx. So this is going to be the right sum, right? So what is going to be this distance? F of A plus, because this side I am taking. No, this side is become the lesser. I need, that's why this side. Include this.
B minus A upon 5, sir. A plus B minus A.
B minus A upon 5. So what is going to be the now area? The function, this distance into b minus a by 5. So this give the area of this box. Similarly, if you do the divide in the box and take the sum. So I am taking the sum here. N is equal to, let's say, so not n. So this sum is 5 times needed. This each time you have to find the value and like find the value of the in here and divide. And see each interval this one, the length of this sub interval is the same. So this is multiply with the same, and each time you are adding with the right side. So this is the right sum also or upper sum. We are taking the right sum or upper sum. the right portion. Each time in this interval, I am taking the right portion, value of the at the right portion.
Right, if
Similarly
it
for
is
the
increasing function, and if it will be decreasing, then this will be lower sum. In case
no, there is no lower and upper mean to say the using this point, using these point, the lower and upper, or right and left sum, left
Yeah,
Riemann sum and right Riemann sum.
I'm telling that if it is decreasing function, then whatever you retain, that f of a plus b minus a upon 5,
Okay, so in that case is going to be layer, so that's better to say upper mean to say left, let's say right Riemann sum. Let's say the right Riemann sum and left Riemann sum. So this case is for if you are in this interval, you are taking this portion, this point for taking the sum. Then you can say this is the right Riemann sum. If you are taking this point for the Riemann sum, then it is going to be the left Riemann sum. That's a good thing to say upper and better to upper and lower. Let's say left Riemann and right Riemann. Clear?
Okay. Sir.
Now this is the sum. Now this is the you are getting the area under, you are dividing the area under the curve in the sub portion, and you are getting. So this is the actually Riemann. Whatever the value at the right portion, left portion, and multiplying with the length of the small interval. This is you can say right Riemann sum. If you are for the case for f, if you are taking this area, this point for this point, so this is a, this length is a, and this is into b minus a by 5, and taking the sum for each box. Similarly for the taking the left. So this is going to be your left Riemann sum. And suppose the case is you are taking in between. I think Sir have did know. I so no need to talk about that one. If you are taking in between point, I think Sir didn't tell about the in between point. Only the left and Riemann sum is definition is there. Okay, fine. So left Riemann sum and right Riemann sum. And final area, if you see, as we did for the now the case we did for the n goes to infinity. Now the same thing you can think. Now what I am doing, I divided the area in n. Okay. So what I am taking the left Riemann sum f of, let's say for each interval, I am taking the left Riemann sum. So left Riemann sum is, let's say, or whatever I'm just writing in the word, I need to be more clarified. Let's say I'm getting the value using the left. So I'm just using the word left into b minus a. Let's say I'm saying this thing is left. I need to in a more prescribed form Riemann. Let's say we will see in the picture and that in the video, and take the sum. Okay, take the sum, and now take the limit, n goes to infinity. This give the exactly area, because now you are divided the interval as very, very small here, and you are always taking the left, and your n goes to now take the limit. Similarly for the right case also, in the both cases it will be the same. N goes to infinity. Now let's say this is the right into b minus a, and in each case this is called right Riemann sum, and it as n goes to infinity, in both cases it will be the same exactly area. In both cases it will give. Is it clear what I mean to say? I left, I wrote, I just wrote here. Is it clear?
No, sir, I didn't get it.
Okay.
Right, what does it mean?
Left means I am taking the point, this one. Okay, so I need to break it. Okay, let me make it here. So the definition, let me show you the definition, or just let me open it, solve it with us. Then I will get the proper notation form.
Left mean the rectangle, the left corner of the rectangle meeting the
left corner I am taking. That's the meaning here. Okay, this is the definition here. So I hope the sum is clear. I still need to tell you the norm of our partisan. So sir used the word partisan. So actually what we are doing, we are doing the partisan here of the interval here. And what is the norm of the partisan is this is the norm. Whatever this is the distance, whatever this breadth. So after dividing this, whatever you are getting, this is the norm of the partisan in the proper word, in the wording form if you are saying. And the same thing is here. Riemann sum in the web data. Okay. Let me write the definition now. Okay. In the proper form. So what you mean to say, let's say you have an interval AB. In this interval, let me open it in the what AB. In this interval, you want to find the area under the curve. So I divided this sub interval in the form of, let's say, as in the 5. So let's say I am divided this in the n interval. So this, what is going to be now the partisan here? A. Okay. A, then let's say this is A here. A, and this is B here. So I divided this in n. So this is going to be x1. This is going to be x2. This is going to be x3. So this is going to be, let's say, xn. So 1, 2, 3, like this. I divided this in the n interval. Now what is going to be the interval? A, x1. Sorry, A and x1. The second is x1, x2. These are the sub-interval, xn and d. As here, if you see the, okay. Okay, and okay, sir is, I just, xn is equal to, assuming you need to be x1, I started. So this is going to be, let's say, this is n minus 1, and xn is going to be the exactly b, and x0 you can say a. So in the proper form of x1 to xn, better to write. So I divided this interval AB in the n sub-interval. So A x1, and here is n minus 1, let's say. So n minus 1, and xn is going to be the exactly b. Or you can change x0, x1, x1, x2, x minus 1, xn. Is it clear? Is it clear till here? Is it clear? No? I just divided the interval AB in the n interval. Dividing form are doing the partisan, means to the partisan. I am here and I am partisaning the interval.
Yes,
Is it
Yes,
clear?
sir.
clear, sir.
Correct, correct.
In
Yes.
n interval. Now, see, this is the rectangle, this is the small sub-interval. Now I am taking the sum using the left, this one. Sum value of the function of the left sub-interval, as here we did. As here we did this one left. So this is, so let's say xi, value of the function, and the length. You are divided each in the n, you are divided, each have the same length, right? So this is going to be your any as here, what is the notation form, sir, using? In the notation form I want okay, length is norm. Now you can say the norm also. See, what is the norm now? Can you tell me? Norm of the partisan. So let's say this is a partisan. This is assume this is a partisan. So I am saying this is, I am denoting it with the P. This is a partisan. Let's say this is P. This is a partisan of interval AB. I am denoting it with the P. Now what is the norm? Norm is actually each have the same length, right? Each interval have the same length. That is the length. The norm is the length. So in the notation form, it is the two vertical braces in between P will be, and this is going to be B minus A by that length. Correct? This is fine. This is the norm.
Yes, sir. Yes.
This is fine. Okay. So this is going to be B minus A.
P is
Right.
the cardinality of this set, sir, means.
No, there is no cardinality. There is no, this include this cardinality is, we used to write only one vertical bar, but here is the two vertical bar. Okay.
Okay.
So this is the partition, and this is in the notation form I am saying. In the proper notation form, everything is the same thing. There is nothing. In standard notation form I'm doing, that's all, in notation form. So this is the norm, this is the left value, and I goes to 0 from 0. See, the value is from 0 left. Now each time you are including the left value of the function at the left side. This is the mean. 0 to n. 0 to n minus 1 we needed, no? Left sum is till n minus 1 will go.
Yes.
Now take the limit. So this is the left Riemann sum. Now if you take the right Riemann sum, again same limit. So this is the left Riemann sum only. If you take the limit, then become the exactly area. So this is the left Riemann sum. Right Riemann sum is I goes to 1 from 1. I need it from 1. So this will become 1. Sorry, this will become n. And this is f of xi. From 1 it will start. And again the norm. Just multiply with the norm. This is the right Riemann sum.
Sir,
Now,
or
if
you can use fxi plus 1 also, no?
X
From 0 to n minus 1 and I plus 1. In place of fxi, we can write I plus 1.
I plus 1. Yeah, we can use.
Right.
Yeah, that's fine. Yes. We can use either we can use this one or this one. So mean to say left and right is this one. Left Riemann is take for the whatever you are dividing the interval, take the left subinterval, left value of the subinterval, and find the value at that point and multiply with the norm. Norm means to the each breadth of the interval. Okay. This is the left hand Riemann sum. Now, if you take the limit now here and goes to infinity, it will give the exactly limit value. Exactly area of the under whatever the area under the curve. Now tell me, is it clear? For example, with an example, it will be clear. I'm taking fx is equal to, let's say, x square. Okay, I am taking an example, fx is equal to x square. And I want to find the area. I want to find the left Riemann sum in between 1 to 5. Okay. And divide in this interval, I want to find the left Riemann sum. Divide this interval in the, let's say, 5 subinterval. Okay, 5 subinterval. So if I want to find, so how I will do? Again, 5 minus 1 divided by 5. Okay, 5 subinterval, it will become a point.
Take 0 to 5, sir.
Yeah, we can take, let's say, 0 to 5. That would be, so 0 to 5, so it will become 1. So that is norm of this partition. Now I am doing a partition, no? 5 subinterval I am dividing. So norm of this partition is 1. Now, what is going to be the partition? What is going to be the small interval? 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. See that? 1, 2, 3, 4, 5. 0 to 5. This is going to be 1, 2, 3, 4. These are the each interval. Okay, these are the interval. I am divided this interval in the 5 subinterval, and this is going to be your. This is the partition, and norm of the partition is 1. Clear? Now I want to find the left Riemann sum. So let's find that. Left Riemann. Okay, left Riemann sum. So what is going to be? So sum, either you can write like this, or f of left value into partition, norm of the partition, plus left value, which is going to be 1 into partition, plus what I am doing, the same box, no? I am finding the area of the box, small box value,
Yes,
that height and the width, height and width, height and again height. This is 2 and width, plus height into width. So for this one, 4. to 5. See that 5 things you 5 boxes, area of the 5 boxes you got here. Now just add them. So f of 0 is going to be 0, 1. Plus f of 1 is going to be 1 into 1. Plus f of 2 is going to be 4 into 1. Plus f of 3 is going to be 9 into 1. Plus f of 4 is going to be 16 into 1. This is going to be 1 plus 4 plus 9 plus 16. So this is going to be whatever the sum we'll get. Okay. So this is the left Riemann sum for this function under this interval after dividing the 5 subinterval. Clear?
Yes, sir. And left will be slightly less than the original area, isn't it, sir?
So left is smaller box. That
Yes.
lower boxes you are including the lower box.
For an increasing function.
For increasing function. Yeah. It's totally depend on the function. Sorry for that. That's why I'm using the word left and right.
Okay.
Is it clear, Riemann?
Yeah,
Okay.
I think we also have to have the middle point Riemann sum, right? So the formula for that is little different, I guess.
Formula is different.
The how if you
for
have
the middle, for the middle, no?
Yeah,
For
yeah.
the middle.
Yes.
Yeah. No, formula is the same. Whatever the
Yeah.
middle term you are taking and the width of the box. Middle, width of the box. Middle, width of the
Yeah,
width of the. There
but
is no,
how would
that's
you
no.
take the middle point, sir?
So middle point, if you are find, just take the middle point. So what is going to middle here? 1 by 2. What is here? 3 by 2. What is here? 5 by 2.
Oh, sir, taking middle point will give the exact sum, isn't it?
No, still it will not get exact sum. There is a small error. We can see where is my.
It's more closer, we can say. Yeah.
No, it's still not more. Still, it will not more close. It will be look like this. Let me show you. Like this. Suppose you have this one, and let's say in this area I want to find in this. This is A and B, and let's say I divide it in 3 boxes. So middle will be here. So here is not. We are unable to see properly. Let's say like this. This is the curve line. So middle, let's say middle is here. So what is happening? We are taking the middle. So middle is here. So what is here happening? Okay. So this box. So here is one, here is one. There is an error.
Okay.
Clear? This is the thing is happening. So this is all about the Riemann sum. And actually when you are doing, so this actually,
Sir,
this one is.
one more thing. For the curves like x square and x cube means the smooth curve, not like this. The taking middle sum will give the exact sum.
No, still, whenever you want to find the exact sum, you have to take limit. You have to take limit. That's all.
Sir, because whatever rectangle you draw, the middle point is always at the means exact at the curve.
Not always. See, here is a small error is happening.
Not
No,
here,
this
sir.
side.
I'm talking about the x square. Fx is equal to x square.
Still, it will be problem. Let's say for x square you are taking. No, this is going to be the graph. Okay, this is 1 and 5. Let's say 1 and 3. So if you take the middle,
it will come at 2, isn't it?
So what is happening here? Small added here, and this portion is something missing. Each time, if you think, suppose each time you are doing, something surely will happen. Whenever you have to take the middle or whatever you have to divide the interval in the infinite of interval.
So the steeper the curve, the greater the error will be.
Yeah, maybe, yeah.
Yeah, sir, I got it.
Clear? So this is all about. So whatever now, see, this is now changed, going to change whatever you are doing now. So left or right. So after taking the limit, it will become an integration sign now. A to B. This is the exactly f of x dx. So whatever you are taking after dividing the very small interval and taking the limit or whatever you are doing, this will become my integration sign. And that's the limit. Integration sign is nothing but a limit. This sign is actually a hidden form. This is actually the limit. Okay. Then these are actually the limit is. A is called lower limit. B is called upper limit. This sign is kind of because of limit is happening. Clear?
Oh.
This is the construction of the sign, you can say.
Sir, when the n tends to infinity, then only, no?
In that case, n goes to infinity case I'm talking.
Okay.
Clear?
And-
The rest portion will
Sir, and the upper limit and lower limit, so n will vanish. There is no need of n.
no, so now you know now you know that, right? A to b x, if you have x squared dx, how you will integrate this? You know the formula. Now you need to know the formula, no? The integration of x square is what? X cube by 3 and limit a and b. What you used to do? B cube minus 3, sorry, b cube by 3 minus a cube by 3. This is the process. If you have remember something from 12th standard.
No, sir, I don't remember.
Okay, so this is called the antiderivative. So find the antiderivative. Okay, so antiderivative means x by 3. What do you mean by anti? So rest all the thing we'll learn in the next lecture now.
Okay.
Now the antiderivative and integration is Riemann. Okay.
Okay, sir.
So this is all about. Till now the Riemann sum I did. Now the antiderivative is here. Okay, and whatever the thing area under the curve. Let's see the Subhasis, maybe take that. Maybe he will explain everything. So is it
Sir,
clear,
just one
Riemann
query. Just one query. Can you conclude for an increasing function, left Riemann will give you the lesser, higher area, and right Riemann will give you lower area, lesser area. Is it right?
Let's see here.
Uh-huh.
For the here itself.
Okay.
For x square, increasing, no, you are saying.
Yeah, increasing function, right.
Okay.
So
For
left
x square we
Riemann,
took, and
so left
okay, I
Riemann will
divided
give you
into
the extra area.
so left Riemann means here is in here it is included. So see that in the interval in this portion, if you think in this portion, so what is the
Right.
left Riemann sum is? This is not left Riemann sum. This is for the left Riemann you have to take.
Okay,
This is
okay,
now the
okay.
left Riemann.
Okay, left Riemann will give you a lesser.
Yeah, lesser area.
Okay, and right
From the
Riemann will
exact,
give you
from the
maximum.
exact area. And the right image gave the more area from the exact area.
Okay.
Okay.
Thank you.
So hope, is it clear to all of you what is Riemann and what is limit, or what we till now we studied something. We discussed Riemann and local maxima, minima, critical computing.
Riemann will remain in our memory.
So is it clear now? Riemann is, I hope, very much clear what is Riemann and how to find. So if you want to get this template, I can give you. This is the template I am giving in chat. You can use this. It will help actually. Many times, just try to analyze the whole thing, what we did here from this. Just change the function, whatever you have now, the query. You just change the function, and whatever the boxes here, just use those all. Just change the limit, whatever the limits or under whatever you are want to do till here or here. It's totally up to you, whatever you want to do. Okay. I am giving the chat. Where is that? Okay. Just use this GeoGebra. Clear? Can we end this session?
Yes, sir. Thank you.
Yeah. Thank you so much. I don't know anyone have doubt from this any activity practice, please let me know. And about the revision session, do you need all of you the revision session?
Yes, sir.
Yes, sir. Of course, we need.
Yes, sir. Log and exponential will be very
Definitely.
helpful.
Okay, we'll ask the TA. Okay, today is Friday. Okay, we'll ask to the TA and we'll try to conduct a session on tomorrow. We'll get an announcement. Okay, we'll plan and then.
And sir, how about the mock? Are we going to get any mock this weekend for week 7 and 8?
Yeah, for not 7 and 8, exactly for the quiz.
Exactly.
for
okay,
which?
covering all the, okay.
Yeah, from 5 to 8.
From 5 to 8 or from 1 to 8?
5 to 8 you can say, or 1 to 8, whatever you want to consider, you can consider, because some concepts uses from the starting to
Okay, okay.
to so that's the mean to say 5 to 8 or 1 to 8. So it's totally up to you how you are considering,
Sir,
because some concepts are using from the starting logarithmic or whatever the things are there, like polynomial, quadratic. Maybe whenever you are solving a logarithmic, and logarithmic, you change the logarithmic in the quadratic. Now the concepts came from the below 5.
Yeah,
So,
okay.
so
Mhm.
better to say, let's say 1 to 8. That's totally up to you how you are considering it.
sir, quiz 2 will be focused mainly on 5 to 8, 5 to 8
Yeah,
or
probably more focus on 5 to 8, because generally you will see the concept more on 5 to 8. Maybe the question uses the concept from 1 to 4.
no, like sir,
That's
set theory are completely different from this 5 to 8 week.
everywhere is the set theory. Like whatever you are dealing with this, what is the domain? Domain is actually a set. So everywhere you are using the set. So better to say 5 to 8, more on emphasis 5 to 8. You can say 1 to 8. Yeah, you are using the concept from 1 to 4 also.
Okay.
Domain, range, those all are a set, no? Taking the integration of the two domain. That is an integration, that is a set theory. Okay.
Okay. Sir.
So this is all about. Thank you so much. We can end the session now.
Sir, can you clear one of my doubt?
What's your doubt?
Sir,
Hmm.
if a function like mod function,
Mhm.
if a graph of the function
Mhm.
means tangent to the critical point is vertical from both side,
Mhm.
then what will such type of function be?
Vertical means what? Tangent is vertical.
Uh, means sir, if we take mod function,
Okay.
so the angle at the critical point is not zero, no? So if it is converging to zero, the angle, this angle,
This angle.
yes, if it is
Okay.
if it is converging to zero, then
So
can we
what do you mean by this converging? It is like this. You are thinking like this, very small, very small. This angle. This is the main to converging zero.
no, it is coming like a curve, not straight line.
Okay.
Coming like
Oh, it is coming like, okay, this is slowly, this is like this.
so no sir, just coming like a curve and making a zero angle at 0 at origin.
So zero angle means, then zero angle means these two lines become a single line, then it will be right.
Yeah, yes sir, yes sir. Sir,
Okay, so what?
take a curve from both side and then make a zero angle at origin.
Okay.
So just draw a graph.
So how will I draw? Like this
No.
lines become a single line. So mean to say that means exactly y-axis it will become. No, it will become y-axis, or this line. This line is, if this line is embedded to this line,
No, sir.
embedded to this line, so it will become a line. For x, for mod x, I'm saying mod x is both side a separate line. This is a line, this is a line with the slope 1, and this is the slope of -1.
Sir, you are taking straight line from both side of a y-axis.
Yeah, because mod x is the gave
I'm
the
not,
right side is a
I'm
straight
not
line, right,
talking,
left side is straight line. Yeah.
I'm not talking about mod function, sir.
Mod x square.
I have seen the such graph actually, and then the doubt came.
Okay, see, first of all, there is angle comes for generally for the straight line, and if you're talking about the angle between the curve, mean to say you're talking about the angle between the tangent of that curve. Okay.
Yes, sir. Yes, sir.
Tangent of the curve, not for the angle between the curve. There is no mean to say that angle between the curve. The angle between the tangent word is proper.
Yes, sir. We can say.
So if you have, suppose you have a graph, and at this point this is tangent. Okay, this is the tangent. tangent, and that's fine. This is the tangent. So you can say the tangent, this tangent angle between these two tangents. So this is going to be whatever the tangent,
Yes.
sorry, angle you are going to take. This is the angle.
If
So
it is
in the
going
positive case,
towards,
this is generally this angle we used to take. So this one. So whatever the angle, whatever that this
if
angle,
you are
this
taking
angle.
that angle, sir, if that angle is becoming 180 degree,
If
then
it
can
will
we
become the same tangent. Then these two different tangent going to become a same tangent, become a line, right? Now, if whatever the angle is, it is become a flat. This is going to be 180 degree. So this
Yes.
line and this line become a single line. Then
Yes.
it will possible, no? That means you are getting the same tangent here, but there is no concept. What do you mean by these things? Okay, there is a possibility that this could happen. This
You
one
just,
and
you take the graph of mod x and you push the both side of line towards y-axis.
okay. So see, push that line. Sorry.
And make a curve. You take a decreasing curve from negative side of x and increasing curve from positive side of x. Then such a graph will be formed.
No, can you see it again, please? Let me know when I will going to take the session. Can you get a clarified question? Then it will, because there is no mean to the, if you have mod function and you are doing this, okay, sir, slowly it become this one, this side, this side.
No, sir.
What? Yeah. Or this angle is going to be
curve.
0. What do you mean by this angle is going to be 0?
Sir,
See,
it will be curve. You are
if it is a curve, if it is a curve like this, okay,
not
this
curve,
is a curve.
just opposite, not like this.
This side.
Like log for curve.
Okay,
Yeah,
this is the log. Okay.
Yeah. You take both side, from both side, take it
Okay.
like.
Okay.
Those both curves are meeting at origin.
Okay. Okay, fine. This one, okay. Okay, fine.
Yeah. And I'm not talking about this the lower part of y-axis. Then
okay. Okay.
Then sir, the tangent, sir, you just erase the lower part.
This one. Okay. I got the point.
Yeah, yes, sir.
Okay.
So,
okay.
And you are taking a gap in between, and if it is if there is no gap, it is converging to almost 0 angle.
Okay.
Then can we say that tangent from both side means left hand side and right hand side is the same, and it is derivative can be found?
No. So this is going to be a sharp corner here.
Tangent will
and
be same,
and there is no tangent. See, there are, mean to say, there can be not tangent. See, what now? Can you tell me what about this one? This is also a tangent at exactly that point. So what you are saying, there is no unique tangent. No, you are not getting the unique tangent. So in that case, this function is
sir,
not
while
differentiable.
defining the mod function, sir told that mod function we are taking tangent which is coinciding with the both the curve. Means,
so are you getting, okay, whatever the mod is also the same thing as happening. Are you getting this? What is happening? This, you are thinking this is a tangent. No, this is not a tangent. So what about this one? Again, you are not getting a unique tangent here.
sir, if we are coming from left side, and so at 0, 0, the tangent will be vertical, isn't it? If let's say
Simply,
we are coming from
I
left
think
side.
you are getting the confusion. See, what about, I am talking about, what about this line? Okay, you are coming to this one, this side, it will become a line. This side, it will become, this side will be, this side will be, This is another line. This is another line. There are infinitely line which become a tangent. So are you getting a unique tangent?
Mm,
No.
no,
Just
sir.
think about it.
So,
This is
sir,
not going to be.
for
Yeah.
mod function, at 0, 0, there are two tangents or many tangents.
The same thing as here. The same thing has happened. For mod also. This one, this even, this even. There are infinitely many going to be tangent, not a unique tangent.
Sir, if we are coming from left and we reach at
So,
0, 0.
so okay. So are you getting no? There are infinitely many tangent.
No, sir.
No.
I am getting that there will be only two tangents. No?
If it is there is two tangent, then can you tell me that then it is going to, can you tell me that that line is going to be a tangent?
Yes.
No, don't. You will not say the tangent. That is not tangent. Tangent means unique tangent. Okay.
Oh, that if we consider the mod function, that line is that not tangent.
That line is not tangent at that point at 0, 0.
Okay.
Yeah, just think about it, because I think see, we are spending more time and one thing, and the second thing is just think about it. What is happening here? If it is 0, 0, so what is happening here? If this line is going to work, it's look like a tangent. See, graphically, don't try to visualize. Okay, graphically, generally visualize for the smooth curve, but don't be confused with the just graphically you are including with the all function. With the all function you are including, you are thinking that such kind of, for all function you are trying to include and thinking that okay sir, is this tangent or that graphical, or this kind of representation saying to be tangent is for generally used for the shop, or it's a very like it is a visible. If it is a
Tangent
very
is the
kind of
instantaneous
very
direction. No?
sorry,
Tangent is instantaneous direction.
yes.
So, sir, direction is only two direction at 0, 0.
So two direction you are getting. So is that tangent is possible for two direction?
No. No,
That's
you
all.
are saying that tangent, multiple tangents. That's why I.
No, don't use the multiple tangent. Tangent means unique tangent, and you can say that direction means in instantaneous direction. You can use the word instantaneous direction. Tangent means unique tangent.
There
That's
are
the word.
only two instantaneous direction at 0, 0.
If it is two instantaneous direction, then that is not going to be a tangent. You will not get the tangent at that point.
But what curve I asked you.
That is also the same.
That is the both the tangent has is coming to just one single tangent.
No, man. If you are coming with this side, you are getting this line. If you are coming this side, you are getting this line.
No. You are making an angle, sir. I'm telling that just it is converging. Angle is 0.
Still, man. Still, that's why you are making a function with the very like you are thinking it is like this. Like this, it is smooth is happening. You are thinking like this, but still, that's why I said you are making a very difficult graph to think about. Okay, see, you are thinking the tangent with the very concise graph. See, this is not case. So that for such cases, you need to go with the algebraic definition. That's from my side.
Okay,
You are including this one with the visualized form and thinking, okay, sir, tangent possible. Think now for such cases, think about the algebraic definition. Now take the left derivative, right derivative, use the left and right derivative is equal to, just say, okay, possibly tangent is, there is a possible tangent. Tangent is actually exit. If it is not, just say this is not tangent. That's all. This is the process only. You are thinking to all function in the visualized form and try to derive the tangent. That's all I will say.
Okay. I've got
Don't
one
be the
query.
confused. Yeah.
Sir, this there was an open session taken on 19th and from 8 to 10 p.m. last Sunday. From 8 to 10 p.m. for open session week 8 for maths.
Okay.
So I'm trying to get that details. There is a YouTube link also, but I'm not able to. Is it that if I click it, I'll be able to open that, or it is not possible?
Yeah, just check the calendar. Yeah, please check the calendar. In calendar itself, the YouTube link is given.
Yeah,
Otherwise,
in calendar YouTube link is there, but when I'm clicking it, it is not coming.
So go with this things with this one. YouTube link with the course thing. What is there?
Okay.
Please go with the important link from here. Just go with the YouTube link. If
No,
it is
what I'm
not
saying,
there,
sir, yeah, if you go to the calendar, you will
oh,
get
here is not YouTube link. Okay.
in the calendar there is a YouTube link is given.
Okay.
So when I'm clicking it, it is not opening. Is it that there is some problem or? I
Okay,
need
let
to-
me check it once. No,
Yeah,
it is
just-
opening.
Is it opening?
Yeah, it is opening.
10th, 19th, 8 p.m. to 10 p.m.
Yeah, it is opening.
Acha, in my case, it is not
Yeah.
opening.
Yeah, just check from.
Maybe there is some maybe problem with the network.
Yeah.
Okay, thank you, sir. Thank you. I think that issue is there.
Okay, sir. Can we leave, sir?
Yeah, you can leave. So don't see these kind of thing. Don't be confused. See, everything you cannot visualize. Everything you cannot visualize. That's why everything. If you are able to visualize, then what do you mean by the limit? If you are able to visualize, then what is the use of the differentiability limit, algebraic definition of continuity or whatever you have? Okay. So if you are such kind of happening, please go with the limit definition. That's the good thing. Okay.
Okay, sir. Okay, sir. Okay, thank you, sir.
Yeah. Thank you so much. Thanks.
Thank you.
Thank you, sir.